Right, so we need to prove that the following expression is divisible by 3. Now first, this looks like an intimidating expression, especially with these large powers right here. So you already know that this will be a very large number and it's pretty hard to tell if it's divisible by 3 or not. However, thanks to modular arithmetic, we can simplify this into a simpler problem. So let's just look at this mod 3. Now notice that we can look at each term and see if it's congruent to something mod 3 or not. So notice that this term, and this term will be all congruent to 0 mod 3. Because notice that from here we can actually factor a 3 out with an integer part inside, like so. Similar thing with 6 and 6 to the 6 and 9 to the 9. They all have a factor of 3. You can check that on your own, by the way. Now, notice that 4 to the 4, 7 to the 7, and 10 to the 10, unlike 3 to the 3, 6 to the 6, and 9 to the 9, all do not have a factor of 3. So we need to do some reducing modulo 3 right here. So let's just work for 4 to the 4 mod 3. Notice that we can reduce this base to 1 to the 4th power, which is obviously 1. And don't forget we're working mod 3 here. So you can see that 4 to the 4 is actually congruent to 1 mod 3. In other words, it leaves an remainder of 1 when divided by 3. Similar thing for 7 to the 7 and 10 to the 10. We can reduce the base of this modulo 3 to get 1 to the 7 and 1 to the 10 respectively, which all result in 1 mod 3. So hence, after we reduce all the terms modulo 3, we get that this is actually congruent to 3 mod 3, which is also congruent to 0 mod 3. Which means if a number is congruent to 0 modulo some number, then that original number is divisible by the modulus or the divisor, I would say. So hence, we've proven that this expression is congruent to 0 mod 3 and we are done.